Hey guys, welcome to lesson 12. In this lesson, we're going to talk about more things about slope, but we're going to get a little bit more in detail about certain types of slope. So if two lines never touch, you have parallel lines, and that's because they have the same slope. And you can notate that by saying, by these double bars here. All right, if two lines intersect, if they're not parallel, they're going to intersect. So most lines will intersect. However, if they intersect in such a way that it forms a right angle, those are called perpendicular. And so that's represented by this upside down T. Sometimes you see a little box right there in the corner. All right, that is perpendicular. All right, and you can tell if two slopes are perpendicular if you multiply them together and they have a product of -1. If it's a product of anything else, it's not perpendicular. Like I said, most lines will intersect. But if they intersect with the product of -1 of the slopes, then it is perpendicular. Another way to think about it is the slopes are opposite reciprocals of one another. All right, so let's talk about this. On number 1, it says finding the equation of a line parallel to y equals 3x and passes through this line. So my parallel slope is 3, so it's the same slope as before. And then I'm going to use the point slope form, y minus -3 equals, my slope that I'm going to use is 3x minus 1. And so that's going to be y plus 3 equals 3x minus 3, y equals 3x. If you subtract the 3, you get -6. So y equals 3x minus 6 is parallel to y equals 3x. They just have different starting points, which is all I care about. All right, what about perpendicular? Well, this, it says the slope is 5. My original equation is y equals 5x, so my slope is 5. But my perpendicular slope is going to be, you're going to flip it and change the sign. So it's going to be -1/5. All right, another way to think about this is if I have 5 times some number and I want it to be -1, set it up like this, solve for m, you get -1/5. That's another way to think about it. Okay, and then I'm going to use a point slope formula. Y minus -5 equals -1/5 x minus -1. Okay, so this y plus 5 equals -1/5 x. All right, that's x plus 1, and so this is going to be -1/5 here. All right, we know that this is going to be 5 is the same thing as 25 over 5. So when I subtract the 5, that's what I'm doing. Y equals -1/5 x minus 1/5 minus 25 over 5. All right, so y equals -1/5 x minus 26 over 5. And that's the equation of my line that is perpendicular to my original. All right, let's keep going. So number 3, it says find an equation of a line that passes through this point and perpendicular to the line y equals 1/2 x. All right, so they told us that it's 1/2 is my original slope. So my perpendicular slope is going to flip that and change the sign. So I end up with -2. And so I get y minus -7 equals -2 x minus 2. So that's y plus 7 equals -2x plus 4. All right, y equals -2x. All right, subtract the 7, you get -3. So y equals -2x minus 3 is my equation here. All right, number 4, this one's parallel. But this one, the equation they gave me, is in general form. So I need to solve for y here. So it's going to be -2y equals -9x plus 5. Y equals 9 over 2 x minus 5/2. So I don't really care about the 5/2, but this tells me that my slope is parallel, and my parallel slope is going to be 9/2. All right, so y minus -8 equals 9/2 x minus -8. All right, so y plus 8 equals 9/2 x. All right, that's going to be plus 8 So that'd be a plus here. 2 goes in 8 4 times. 4 times 9 is 36. So I got 36 here. Y equals 9/2 x. That's going to be 20. Subtract the 8, you get 28. So plus 28. Okay. 5 can be tricky if you're not paying attention. All right. So it says find the function that passes through this point and perpendicular to the line x equals -17. Well, x equals 17 is a vertical line which has a slope of undefined. A horizontal line and a vertical line are perpendicular to each other. So if you have a slope that's undefined, the reciprocal of that is going to be 0. So my perpendicular slope is going to be 0. All right, well, if it's a horizontal line and my slope is 0, I don't really need to go through the whole process of finding point slope. All I need to do is look at my y, and that's going to be y equals 5 for my equation. For number 6, it says find the function that passes through this point and perpendicular to the x-intercept 2 and y-intercept -4. Okay, well, remember, if my x-intercept is 2, that means this is 2, 0. And if my y-intercept is -4, that means this is 0, -4. And so I'm going to use these 2 points to find my original slope. And so that's going to be m equals -4 minus 0, 0 minus 2. It's going to be -4 over -2, which is going to give me +2. All right, so that's my original slope, which means my perpendicular slope is going to be, flip that and change the sign. So it's going to be -1/2. All right, so I got y minus 5 equals -1/2 x minus -4. All right, so y minus 5 equals -1/2 x. All right, so there's going to be +4, and positive times negative is negative. Half of 4 is 2, so it's -2. Add the 5, y equals -1/2 x plus 3. Okay, so that's how you do those. Now, what about pulling from data charts or word problems? Okay, so it says an average annual tuition and fees for in-state students at public four-year colleges are shown in the table for selected years and graphs as the order pairs in points. All right, so the table's on this page, the graph's on the next page. We'll look at the graph in a second. X represents 2009, X equals 1 equals 2010, and so on and so forth. So let's just go ahead and make note of that. So 2009 is 0. That means this is 1, 2, 3, and 4. And it tells me that I want to create an equation of the graph for this data. So the best thing you can do is pick your most extreme points, in this case 0 and 4. And this gives you your best. The overall data may be linear, or may be close to linear, but it may not be linear. So picking these two extreme points, the low end and the high end, would give me the best guess of exactly where that line would be. So slope is going to be, let's see, 80/70 minus 63/12 over 4 minus 0. Okay, and if you use your calculator to help you out, this is going to be 1758 over 4. And we're going to go ahead and get that at decimals. So that's 439.5. And so my equation is going to be 439.5 x plus 6312. Because remember, if x is 0, I'm dealing with my y-intercept. So this first point here is my y-intercept. Okay, so that's my equation. Now, I told you we would look at the graph next, so let's do that. On the next page, it says, use the equation from Part A to predict the cost of tuition and fees at public four-year college university in 2015. Okay, well, the 2013 is 4. That means 6 is 2015. And we're going to figure that out. Figure out what that tuition cost is going to be. So we're going to take our function that we just made on part A, and we're going to plug in 6 for x. So y equals 439.5 0.5 times 6 plus 63.12. And just crunch the numbers in your calculator, and you're going to get 89.49. So in 2015, that's what the tuition would be based on that model. Okay. All right, average rate of change. You know what this is before I even tell you. This is the slope formula, but it's just another name for it. Okay, so another way to write the slope formula using function notation is called the average rate of change. So when you see average rate of change, you should think slope. Okay, so how this usually works is like on number 8, it gives you a function and it gives you 2 x's. So I need to find the y's for those x's. So f of 0 is, and then f of 2. All right, so that's going to be 8 times 0, which is 0. 8 times 2, which is 16. And now that I have the x and y's for both points, now I can find slope. So this would be 16 minus 0 over 2 minus 0, which is going to end up with 8. Okay, but of course we already knew that because it's right there. But that's your answer. Now, on number 9, you have this graph here, and it says in 2009, Google spent $2,800 million on research and development. In 2013, they spent $8,000 million on research and development. Assume a linear relationship. Find the rate of change in the amount of money spent on R&D. So you're going to take the 2 points they gave you and find slope. So they said that we're going to start with the big point. So 8,000 minus 2,800 over 2013 minus 2009. Okay, so on the bottom we get 4. On the top we get 5,200. And that's going to result in 1,300. All right, so what does 1,300 mean? It means that the graph shows a $1,300 million increase in R&D each year. All right, one more problem. So whether you're talking business calculus or anything like that, one of the more common linear functions is your cost function, revenue function, and profit functions. And this is how much money you make and how much is it going to take to make a profit, and so on and so forth. Okay, so assume the cost to produce an item is a linear function and all items produced are sold. The fixed cost, which means like all your upfront costs. So if you're starting from scratch, you need some seed money to get you started, to buy the equipment and all the things. So the fixed cost is $1,500. The variable cost is, or the variable cost per item is $100, and the item sells for $125 a piece. How many items must be sold for the company to make a profit? All right, so first thing we need to do is we need to figure out what our functions are. All right, so fixed cost is $1,500. Variable cost per item is $100. That is my cost function. All right, so that's going to be 100x plus 1,500. Remember it said it's a linear function, so we're modeling this after the y equals mx plus b equation. Okay, then it says that the item sells for $125. That's my revenue function. And my revenue function is price per unit sold times x. So that's going to be 125x. All right, how many does it need to make a profit? Well, my profit function is this, revenue minus cost. So I got 125x minus, and because this is 2 terms, I'm going to put in parentheses, minus 100x plus 1,500. All right, and I put it in parentheses because I got to distribute that negative. All right, so I got 125x minus 100x minus 1,500. Clean it up. You get 25x minus 1,500. Okay, so that's my profit function. When do I make a profit? When this is greater than 0. All right, so 25x minus 1,500 greater than 0. I want to know when this is true. All right, so 25x greater than 1,500. Add the 1,500 to both sides, and I divide by 25. X is greater than 60. All right, So it says greater than 60, which means at 60 items, I'm still not making a profit. If it's a greater than or equal to 60, that means 60 items would turn a profit. So that means at least 61 items must be sold for this company to make a profit. All right. All right. So that's it for this lesson. I hope you got something out of it. Reach out if you need help, and I'll see you in the next one.